So, yeah. Okay, so we have just started. So this is problem 13 and we know sections and everything. So we write them. K be a field and capital K be the, so I suppose all of you have the book, but I'll just write the question. Rational function field in one variable and sigma and tau be the automorphisms of K defined by this and this. Determine the fixed field of this and determine this as well. Okay. A be a field. Then we look at the function field. Sigma and tau are in this. Sigma is defined as tau is defined as this. First question is determine fixed field F of, so of the group generated by sigma and tau, or it will be the same as fixed field of these two automorphisms sigma and tau, because these two will be the generators of that group. So the question just states determine the fixed field of this. Try it. So it's fairly explicit. We just need that f of 1 by x by g of 1 by x is equal to fx by gx. And also equal to f of 1 minus x by g. So of course there are some obvious candidates, right? So if so if f 1 minute. If f is a reciprocal polynomial, which is I just say if the name is not meaning that, I mean, if you just have this condition, right, f of this, and you know what this means, this just means that the coefficients are symmetric, right? So a0 will be same as an, and a1 will be same as an minus 1, n is the degree. And of course we need one more condition, this one. So basically, maybe I will erase this and say that this is certainly a sufficient condition. And my question is, how do these polynomials look like? In which f of x is same as f of 1 minus x. We don't maybe need to find the polynomials explicitly, but still, right. So these are just the polynomials which are symmetric about x equal to half, right? Or I'm sorry, symmetric about the line y equal to half. Okay, these. And yeah, I don't know if there is a more explicit description. Yeah. So what we can say then so far is f contains f by g such that and also of course g also has the same. The question is, are these all? I mean, the explicit description is a different kind of question. I don't know if they are asking for that. They might be. Because but okay, first let's settle if these are all the polynomials, then we will try to determine them explicitly. So from this, can we prove these things? Can we prove these equations? Yes, right, that should be true. Because it's like these are in the lowest common, sorry, reduced fractions. We are assuming these are reduced fractions. So that we can assume. Okay. And then we can say this. So yeah, so we just use the fact that this is a UFD and so on, right? So you just write maybe x to the n f of 1 by x. Okay, but the degree, ah, no, so then something is, okay, let's see. Can we say the degree of f and degree of g is same? So from this, like this part will be analogous, so we don't have to worry about it. So from the first equation, can we say that the degrees are same? Because if you can say that, then it will be done, because then you would know that this gx uh, is co-prime to fx, right? So it must divide this. And yeah, and similar, but the degree is same, so it should be equal, right? I mean, degree of this and degree of this is obviously same, so it will be equal, and then it will be done what we want to prove, right? So I mean, yeah, so I'm sorry, when I write this, of course this makes no sense, in the sense that one has to of course put x to the n here. That's always there, otherwise it's not even a polynomial. Means x to the degree, that has to be there. So now we have reduced the question to asking if the degree has to be the same. Let's just think about it on the next page. This should be simple. Yeah, has anybody just write it explicitly and check it? Just yeah, in this case, the degree has to be same, right? Because you can just look at this first page, just put x equal to 0, because now you think of them as functions. Just put x equal to 0, then the LHS is not equal to 0. So this should also not be 0. So n should be equal to m. Yeah, so if we just continue looking at it, so x and there's a 1 by x. Yeah, so the degree may not be the same. It will just be the difference of certain things. So if you just, yeah, so I'll just say it explicitly. So you just take like r, let's say x to the r, and then you have x to the m. So I'll leave this for you to check. Okay. Degree is not the same. The difference in the degree will be equal to the multiplicity of 0 of g. Okay, something like that. But that is probably not very important here, so I'm not getting into it. Okay. So, all right. Yeah, I'm sorry. It is important. Uh, this, and then you want to, if, okay, yeah. So let's do one thing. Okay, let's work with the case in which f and g is 0 are not 0, and the other case I will leave for you to check. Okay, it's similar. You have to just make some small adjustments. Okay. So under this assumption, we are getting that the degrees are same and they have to satisfy this kind of thing. Okay, and so this is equal. Okay, and the other case is not difficult, but you have to just do some small adjustments. Means it seems to me that you have to just do some small adjustments. So I will not get into it. So in fact, then it looks to me that this is the answer. This is the fixed field. So let's just erase these things. In the end, it's like, yeah. So this is the field that is fixed. So it is the field generated by these polynomials of these kind. Okay. That something seems wrong, right? No, no, no. Right. So, yeah, the problem is that unless I consider the case in which g of 0 is also 0, I will not be able to describe this field. Because see, I mean, if f of 0 is not equal to 0, g of 0 is not equal to 0, okay, uh, and then you see that the degree of f equals to degree of g. Okay, yeah, and the degree of f equals to degree of g. Okay, if you have this, then it implies that f by g is in f. Okay, that is something which we just checked, but let's just check it again because I'm a little confused. We should just uh, yeah, I mean, so it just comes from sorry, just comes from writing it. So this is true. But just a minute. Oh yeah, I'm sorry. Yeah, so it seems then that the degree considerations were completely unnecessary, right? It, yeah, yeah, because you see, I mean, so Certainly, if you just have this, then so this is certainly inside this. There is this we remarked right at the beginning. Certainly inside this, and then we were trying to prove that it is equal. Okay, and if there is f and g in the fixed field, okay, if this happens, okay, I'm sorry, if this happens, then we were somehow um, yeah, where is the confusion? Okay, so if this happens, okay, let's remove this. So let's say that f by g is in this. Yeah, that's the problem. So we should not avoid the point. I am, yeah, it is only this. Okay. Yeah, yeah. So there are certain mistakes. Wait, let's just do it again. Yeah, let's just do it from scratch. I've been writing, but I think now it will not should not take as much time. For some reason they are showing a time limit here, so maybe I will just write on Jamboard. Okay. So never mind. We know the question.